Close your eyes for a moment and imagine the following scene. You wake up on any given morning, have your breakfast, open your house window and, when looking at the sky, have the absolute certainty that at this exact moment there are human beings walking, working, and living on another planet. It's not science fiction, it's not a Hollywood movie, it's reality. Mars, that reddish point that shines in the night sky since we were children, now houses an entire human civilization. Seems incredible, doesn't it? But are we really as close to this reality as Silicon Valley billionaires want us to believe? This question has been haunting me for months, and I'm sure it also awakens your curiosity. That's why I decided to dive deep into this question and discover the truth behind the grandiose promises about Martian colonization. And what I discovered will completely surprise you. The answer is neither as simple as optimists preach, nor as impossible as skeptics claim. It's something much more fascinating and complex than any of us imagined. To begin understanding this story, we need to go back in time and discover how humanity fell in love with Mars. It wasn't love at first sight, but rather an obsession that grew over more than a century. In the late 1800s, an American astronomer named Percival Lowell was convinced he had discovered something extraordinary in his observations of the red planet. He believed he had seen artificial canals crossing the Martian surface, constructions that could only have been made by a highly advanced civilization. Lowell imagined that these canals were a sophisticated irrigation system created by Martians to transport water from the icy poles to equatorial regions in a desperate attempt to save their dying planet. It was a completely speculative theory based on limited observations and much scientific optimism. But this idea caught fire in the popular imagination of the time. Newspapers, books, and artists began to portray Mars as the home of the famous green men, creating a collective fascination that, in a way, paved the way for all the space exploration that would come later. Decades later, in 1948, something curious happened. German engineer Wernher von Braun, who would later become one of the central figures of the American space program, wrote a book detailing what a possible human colonization of Mars would be like. In his science fiction, a group of 70 astronauts arrived on the red planet and discovered that the Martians were led by someone called Elon. Yes, you heard that right. Elon. An astonishing detail that gains almost prophetic contours when we observe today's reality. But it was only in 1976 that humanity took its first real step toward Mars. NASA managed to land the Viking 1 and 2 probes on the Martian surface, marking the beginning of the era of robotic exploration of the planet. This mission was historic not only for the technical feat, but also for the ethical dilemmas it raised. There was a real fear of contaminating Mars with terrestrial microorganisms, which could forever compromise our ability to discover if native life ever existed on the planet. The great Carl Sagan, one of the greatest scientific popularizers in history, brilliantly summarized this dilemma when he said that if there is life on Mars, then Mars belongs to the Martians, even if they are just microbes. This reflection forces us to think about our responsibility as cosmic explorers and about the ethical limits of space colonization. Since then, we have sent 10 other explorer robots to the red planet. Names like Spirit, Opportunity, Curiosity, and Perseverance have become familiar to anyone interested in space exploration. These rovers have mapped terrains, studied rocks, drilled soil, and searched for signs of life with a precision that would have been unthinkable decades ago. And the discoveries have been absolutely fascinating. We found evidence of ancient lake beds, complex organic molecules, and huge deposits of ice buried beneath the Martian surface, including in areas near the equator. Scientists estimate that if all this ice were melted at once, Mars would be covered by an ocean 115 feet deep. It's an impressive amount of water and definitely encouraging for those who dream of colonization. Abundant water, an atmosphere rich in carbon dioxide, easily accessible ice. It seems like Mars is calling us, doesn't it? But here we come to the first major obstacle. Mars is definitely not ready to receive us with open arms. In fact, it's trying to kill us in every possible way. The red planet has no magnetic field of its own, which means its extremely thin atmosphere, with less than 1% of Earth's atmospheric pressure, offers zero protection against deadly solar radiation. An astronaut who made the trip to Mars would be exposed to a radiation dose equivalent to between 400 and 900 chest X-rays. This is not just uncomfortable, it's potentially lethal. Radiation compromises DNA, dramatically increases cancer risk, and irreversibly weakens the immune system. And gravity? Mars has only 38% of Earth's gravity. It might seem fun at first, like being in a giant version of those inflatable toys where we can jump higher, but the long-term effects are devastating. We already know, through studies with astronauts on the International Space Station, that low gravity causes significant loss of muscle mass and bone density even in relatively short periods. On Mars, it would be a biological adaptation for which our body is simply not evolutionarily prepared. Now imagine we manage to overcome all these biological obstacles and have a spacecraft ready to land on Mars. The next crucial question is, land where exactly? And here we enter a fascinating scientific and ethical dilemma. The most scientifically interesting locations, where there's the greatest probability of finding signs of microbial life, are exactly the same places where it would be ideal to establish a permanent human base. We're talking about low-altitude areas, with higher atmospheric density, guaranteed presence of ice, and good exposure to sunlight. But if we land in these locations bringing our own terrestrial microorganisms with us, we risk irreversibly contaminating these environments. The result would be that we would never know for certain whether the life we found there is genuinely Martian or if it's just our own terrestrial organisms that adapted to the environment. That's why the Mars Sample Return mission is so fundamental to our understanding of the planet. NASA is preparing to bring back to Earth in the coming years soil tubes carefully collected by the Perseverance rover. Only with this material analyzed in highly controlled terrestrial laboratories will we finally be able to answer the trillion-dollar question, was Mars, or is it still, an inhabited planet? While the scientific community works with this methodological caution, Elon Musk accelerates the pace in a completely different direction. His company SpaceX is developing Starship, the largest and most ambitious rocket ever built by humanity. Made of stainless steel, a cheaper and more resistant material than traditional alloys used in space vehicles, the rocket is completely reusable, can be refueled in orbit, and, in theory, will be capable of producing its own fuel on Mars, using carbon dioxide from the atmosphere and underground ice. Musk's declared goal is to make the trip to Mars economically viable for human beings. Today, sending any object to space costs thousands of dollars per kilogram. Transporting a single human being with all the necessary life support equipment would require the equivalent of 10 rockets the size of the historic Saturn V that took astronauts to the moon. Musk wants to reduce this cost to a few $100,000 per person, making the trip accessible at least to the global upper middle class. But reality has proven more challenging than optimistic projections. Of the 8 Starships launched so far, 4 completely failed in their objectives. The others had partial successes, but are still far from demonstrating the reliability necessary to transport human beings. The technical challenge is monumental, and time is definitely working against us. The ideal orbital window for travel between Earth and Mars opens only every 26 months, when the planets are in favorable alignment. Even so, 6 to 8 months of travel are needed to cover the distance. This means that a group of colonists who departed in 2033 could only receive reinforcements, supplies, or any kind of support from Earth in 2035. They would need to survive completely alone for 2 whole years, dealing with all technical, medical, and psychological problems that arose. One of the most popular ideas in science fiction is the terraforming of Mars, the process of transforming the entire planet into a habitable version of Earth. But when we analyze the real numbers behind this proposal, the reality is absolutely astounding. To make Mars truly similar to Earth, we would need to raise its current atmospheric pressure from just 6 millibars to something above 100 millibars. Simultaneously, we would have to raise the average planetary temperature from -81 degrees Fahrenheit to at least a few degrees above 32 degrees Fahrenheit. One of the theories most debated by scientists is to release all the carbon dioxide trapped in the Martian polar ice caps, melting the so-called dry ice and creating an artificial greenhouse effect. But even if we managed to accomplish this feat of planetary engineering, we would reach only half the necessary atmospheric pressure. And to execute this project, we would need more than 80,000 times all the current energy consumption of terrestrial civilization. Other proposals include purposely colliding nitrogen-rich comets with the Martian surface, or creating artificial dust layers in the atmosphere to capture and retain more solar heat. But all these ideas are highly speculative and would be talking about projects that would take not decades, but entire centuries to become reality, if they ever become technically possible. So, after all, are we going to Mars or not? The honest answer is much more nuanced than a simple yes or no. Complete and permanent colonization of the planet may indeed take centuries to become reality. But a permanent scientific base with regular rotation of researchers and technicians might be possible still in our generation. The most important thing is that we need to approach this exploration with extreme caution and responsibility. We cannot allow the same mistakes we made on Earth to be repeated on a cosmic scale. Space exploration has the unique power to unite entire nations, inspire future generations, and expand our fundamental understanding of the universe and our place in it. As Carl Sagan brilliantly said, perhaps the greatest value of this quest is not necessarily building colonies or terraforming planets, but discovering something even more precious, that we are not alone in the cosmos. Maybe we will never completely terraform Mars. Maybe we will never have those futuristic cities under glass domes that we see in movies. But if our presence on the red planet is conducted with responsibility, scientific ethics, and respect for the unknown, maybe we will find something even more valuable than a new home, a new purpose as a species. If this content awakened your curiosity about the mysteries of the cosmos, leave your like, subscribe to the channel so you don't miss any fascinating discovery, and share with everyone who also dreams big and looks at the stars. To continue exploring the limits of science and human imagination, click on the next video that's appearing on your screen right now. See you soon. Who knows, maybe even on Mars.